Chapter 7. A Steady March. The Scribe's Note on Chapter 7. The steady motion of electrons from atom to atom along a wire or other conductor constitutes the well-known electric current. The moving electrons disturb the ether around the wire and produce what we know as a magnetic field. The electron explains why it is necessary to have a complete circuit before any electric current can take place. Also, how one length of wire may be used to connect two distant places, provided the two extremities of the wire are buried in the earth. End of Scribe's Note. Personally, I knew nothing about marching until quite recently. Indeed, none of my fellow electrons seem to have had definite ideas of regular marches previous to the last century. That century is prominent in our history as well as in man's. There is no doubt that before then we must have made more or less regular marches through the crust of the earth and elsewhere, but for myself I have no such recollection previous to the following occasion. The experience was not a very exciting one. I found myself passing along from atom to atom in a copper wire. But what was of special interest to us was that it became evident that these enforced marches were being deliberately controlled by man. Of course, you will understand that man knew nothing of our existence at that time. All he knew was that when he placed a piece of zinc and a piece of copper in a chemical solution, there were certain effects produced in some mysterious fashion. For instance, when he connected the top of the two metals in this chemical cell or battery by a piece of wire, he got what he described as an electric current. Now all that happened really was this. The chemical action in this battery which man had devised caused a rearrangement among the atoms composing the metals and the solution, with the result that we poor electrons had to rearrange our domiciles. As an accumulation of electrons gathered on the zinc, some of us were forced along the connecting wire towards the copper. As long as the chemical action in the battery was kept up, so long we were kept on the march from the zinc to the copper by way of the wire. Man tried increasing the length of this wire bridge across which we had to pass, but we had no difficulty in making our way along. But you must not run away with the idea that we rush along the wire with lightning speed. Although we can fly through the ether at a prodigious speed, our progress from atom to atom in a wire is more like a snail pace. As a matter of fact, our rate of march is much less than the walking pace of a man. Indeed, it may be stated conveniently as so many yards per hour. Some people may find it difficult to believe that our rate of march is so very slow. Their front door is a good many yards away from their electric bell, but it does not take us an hour, or any appreciable part of a minute, to summon the maid. The secret is that there is a whole regiment of us along the wire, and before one of us moves on to a neighboring atom, another electron must move off that atom and on to its neighbor, and so on. In this way the electrons at the far end of the wire commence to move at practically the same moment as to those near the battery. It has been a source of amusement to me to see people perfectly mystified by the fact that they can get no electric current unless they have a complete circuit. What else could they expect? How could man march if he had no road to march on? You see, the reason for our march is that we wish to escape from the overcrowding on the zinc, and we are forced towards the copper. The atoms composing the wire are our stepping stones, and if there is not a complete chain of atoms, we are helpless. You have already heard how we can jump an air space under very great pressure, but that condition does not exist in the present case. When we are disturbed by the chemical action of the battery, we should prefer to have a short cut from the zinc to the copper. But if the only path man gives us is by way of a long wire, then we must be content to travel that road in order to reach the copper. It is a matter of little moment to us what arrangement man makes as long as he gives us a complete path. For instance, he may lead us out from the zinc to a distant telegraph instrument, and then, instead of providing a second wire to take us back to the battery, he may conduct us by a short wire to the earth. We are quite content to lose ourselves in this great reservoir, provided man places another short wire from the earth to the copper of the battery at the other end of the line. Then, as we slip off at the one end of the line, an equal number of electrons can climb up at the other end, and thus enable all our friends in the long wire to keep up a steady march. This march of ours is not merely a means of transporting ourselves from one place to another. It is to enable us to do work. It is only when we are in motion that we can do useful work, for we must move before we can disturb the ether, and it is by means of the ether that we transmit energy. If you place a magnetic needle or mariner's compass near a wire along which we are making a steady march, you will find that we can affect our fellow electrons who are stationed within the magnetic needle. We cause the needle to swing round and take up a position at right angles to our line of march. We succeed in doing this because these electrons in the magnetic needle are on the move also. But this reminds me that I have never told you how we produce the ether disturbance which you call magnetism. When, as children, you played with toy magnets in the nursery, little did you think that there was a host of tiny electrons amusing you, and yet we electrons are responsible entirely for all magnetic effects, as I shall proceed to explain. End of Chapter 7.